Welcome everyone to track 2. So today I'm gonna present a work called Empathic Response Generation in Chatbots. It was a work made mainly by Timo Spring, but is not here today, so I am here. And I come from Fribourg, from the Human Tech Institute. And this is an institute which aims at improving the quality of life of human being, basically. So chatbots is in the topic, and I will talk to you about this today. First, you may know that chatbots are everywhere now. You can check your bank account. You can book a flight with chatbots, and all of these chatbots are mainly of transactional nature. Okay, so if you want to order pizza, you have to give the ingredients, to give the location, and then you will have it. But it's not a real human versus human conversation. So what we want to do, and the efforts about this aim to create more personalized chatbots for deeper and emotionally charged conversations. And this is empathy. So the goals of this type of chatbots are first to boost the usage of chatbots, because now we know what a transactional chatbot is and we want to go further. With this, the users should feel better, and we want to provide not only a service but an experience. And finally, we want to make the interaction more natural and human-like. And for this, we have empathic chatbots, and we have two main applications for this technology. The first one is customer service, and the second one that I'm going to talk today is treating mental illness. So for the first one, I'm going to give you some numbers here. By Gartner, they said that by 2020, 25% of customer service requests will be made through a chatbot. A group analyzed 1 million of tweets about service requests, and the result is that 40% of the messages express emotions, attitudes, and or opinions, and not just asking something. Plus, the average response time of these messages is 6.5 hours. So we should make this shorter, maybe. So having empathic chatbots in this domain could help improve this domain in 3 ways. By first, reducing the response time. Second, by reacting to specific user emotions. And third, to reduce the cost. So now the second application is mental illness treatments. So thanks to the Swiss Health Observatory, we know that 20% of Swiss population suffers from at least a slight depression, and they have the same numbers in the US, and they say that the cost of this is around $210 billion annually. The third point here is that we lack some professionals in mental professionals. Hard to say. So it's difficult to treat and to detect people that have this mental disease. So with the empathic chatbot, we can find quicker the person. It is easy to scale and to answer to many people at the same time. Okay. And so, yeah, this is a good application for empathic chatbots. We already have some empathic chatbots on the market. The first one is WooBot, and its goal is to have a companion that you can talk to, that coaches you, and it uses the CBT. It's a cognitive behavioral therapy used to treat anxieties and mostly depressions. So it seems to work now. They made research about depressions on many people about this, and it seems to be really good at it. And the second one is a replica. This is a digital companion as well, and the goal is that you can talk to replica anytime you want, and it can listen to you and reply, and yeah, it can help people socialize. But now, what is empathy? So if you have a sentence here, you can answer by saying you were late only, and this is neutral. But you can, if you have empathy, you can say something like this. Okay? So here because there are many definitions of empathy, and so we want to use the affective empathy, and this is mostly first to understand the emotion of the user, and second to reflect on this emotion. And I'm going to explain to you how to reflect the user emotion later. So I think now we can start with the main part, and this part is this. So this is the architecture, I would say, of my presentation. So first we want to express an emotion, so that the user expresses an emotion, and then we receive it, and we want to detect the emotion that the user wants to transmit. The third part is the response generation. We want to understand and to respond adequately. And the fourth part is the response expression. So we start with emotion expression. And with this, we have to know what is an emotion. So for this, we have different models of emotions. One of the famous is the Plutchik wheel of emotions. It contains 32 emotions, and you can see this on the wheel, but this is a lot. And most of the time in this domain we use the Ekman's 6 basic emotions, because when you want to classify something, for example a text to an emotion, it's easier to classify into 6 categories than into 32 categories. So most of the time we use these emotions that are anger, disgust, or typo here, fear, happiness, sadness, and surprise. So for the rest of the talk, when I will say something about emotion categories, it will be these 6 categories. So when we express emotion in a chatbot, it's hard because we are human and we use non-verbal cues, like we move our hands, we make facial expression, and when we text to a chatbot, we cannot do this. So it's difficult, and we have 3 different complications, I may say, that, for example, we can have an implicit expression that what we want to say is hide behind something. We can have context-sensitive information like this. If we don't have the previous utterances, we don't know what really emotion is. And the third problem is that the text can be multi-layered. It means that in this case we have multiple emotions, and maybe the total emotion is not the sum of these two, and yeah, we can have different problems to detect the emotion. So we can jump into the second category where we want to detect the emotion. And for this, we try to classify all the method into 3 different categories. So I don't know if it's objective, but we choose to do this. The first one is the rule-based approach. The second one is the non-neural machine learning approaches. And the third one is neural networks and all the deep learning approaches. For the first one, so it's the rule-based approaches. So the first one is the emotion lexicons. So emotion lexicons are just lists of words that carry an emotion. For example, we know that love carry usually a love emotion. So we just get words from the text and we have the emotions. For this, we have different existing lexicons like WordNet Effect or Depeche Mode. And we see that the quantity of words here is really different. We have 5,000 words and here 37,000 words. So the quantity is not the quality. Sometimes it's better to have less words. So it depends on the situation. And we have also, these are general purpose lexicons, but we can have domain specific lexicons, and they can be better at the task depending on the task. The second rule-based approach is the word embedding. So here we take a huge corpus of text, and we try to map each word in a vector space in order so that the semantically correlated words are near from each other in the vector space. So here we can see it's the usual graphs that we have for word embeddings. So maybe the distance between man and woman is the same as between king and queen. And here it's represented in 3 dimensions, but usually can be in 100 dimensions or so. And famous examples of embeddings we have are Word2Vec or FastText or others. But with this rule-based approach, we have drawbacks. So the first one is that if we have a sentence without emotional keywords, so we cannot classify the sentence. And the second one is that we can have ambiguous emotions in text. For example, in the sentence, I hate her, it can be anger because of the word hate, but if it can also be sadness depending on the whole sentence. So I go to the second approach, that is non-neural machine learning, and here we have 2 big categories that are unsupervised learning, and the second is supervised learning. For the second one, we have to label each sentence to an emotion, okay? And this is sometimes painful, but again, we have already a labeled data set to help us. And the drawback, no, not the drawback, but with this approach, sometimes most of the time we have unbalanced data set. This means that in a data set, we have more examples of joy than sadness. So the result will probably be unbalanced. And the data set we use for this approach are usually movie dialogues, mainly for unsupervised learning. And also it can be tweets. And the advantage of tweets is that we can have label, because people sometimes write hashtags, so it's labeled for us. And also emojis. And finally, the third approach is deep learning. So in this space, we have a lot of advances in the last years. So the standard approach, I would say, is this one. That we have a fixed vector in the input, then we have the network, and we have a fixed vector in the output. And with text, it's not that easy, because if I say, how are you? It's how are you? It's 3 words, and I can answer, I am good. It's okay, because we have fix, but sometimes we want to answer something else. So we don't want to have fixed output. And with this, we have RNN, that are recurrent neural networks, that allows us to do, for example, this. So here, we have 1 word to each input, and we can output 1 emotion, for example. Or we can have a network like this, that we input the different words, and we respond with another sequence of words. And as you may know, is that this approach is a mix of emotion detection and response generation, because we take the input, the text, and we output directly the response. So we don't have the emotion in the middle. But I will explain this a bit later in the response generation chapter. So here we have to beware at first that we want sometimes to focus on the content level information, but we also want to focus on the emotion level informations. And this is usually not easy, because when we optimize one, we sacrifice accuracy for the other, usually. So we have, again, two strategies. And the first one is retrieval-based. This means that we want to check for the sentence and see if we have a similar response in our data set, for example. And the second one is dynamic generation. This means that we create new text to answer the user. So the first approach is just to look to common responses in a data set. But this gives us a problem, is that if we don't have a similar sentence in our data set, most of the time we will answer, I don't know, because we don't know, because we don't have the data. So for this, we have a second approach that is using, again, the word embeddings. So we look for similar words in the vector space and search for similar responses. But this requires lots of emotionally charged sample conversations to be good. And now second is the dynamic generation. And so it's what I told you before. So these kind of architectures are called encoder-decoder, because we have the first part that is the encoder, and this is the decoder. So here we just, at each step, we input a word to the network. So maybe here, har, then you, then free, then tomorrow. And with this encoder, we just generate a fixed size vector, that is the third vector here, to represent the sentence. And with this, we have another part that is the decoder that can generate the response we want. Okay, so I'm not gonna explain the entire history of this kind of networks, but we have a lot of problems, because when we have long words, we cannot, what do I say? We can forget the first words when we are at the end of the sentence, for example. So for this, we have new types of networks, like long short-term memory. So with this, we can remember more the words of the beginning. And we have other mechanisms like attention mechanism, etc. So you remember that I explained the content versus the emotion. And all of the previous methods I explained are focused on the content level information. So we have now the emotional chatting machine, the ECM, proposed by Joe and all, that focus more on the emotion part. So it is trained on 22,000 Chinese blog posts, and they are all annotated with the 6 basic emotions of Ekman's. It is based on a sec-to-sec architecture, this one. And for this ECM, they added internal and external memory to deal with the emotion. And this is the total architecture. So I'm going to explain just the training part. So we have a corpus with a sentence and the answer, okay? With this, we want to classify with the emotions. So we have this training set. So we have, again, the utterance and the response with the corresponding emotion. And then we can train the emotional chatting machine, and it will learn how to respond and how to respond with a specific emotion. And then when we want to use it, it's the part on the right, and this is detail. So we input the sentence we want to answer, and we also input the emotion category we want. This means that we will we will this means that we will manually enter the emotion that we want in the output. So it will not recognize the emotion of the sentence, but it will produce an emotional response with the emotion we want. And with this system, it performs really good on the emotional level on all 6 categories compared to all the other networks, but not better and even slightly less good in the content level information. But what about empathy? So, because now we have emotion, but just emotion are not empathy. So the first strategy is just to mirror the user emotion, but this is not always empathic, okay? Because if I'm sad, I don't want you to answer in a sad way. I want you to cheer me up, okay? And a second approach is to follow the evolution of the emotion through the conversation. But about empathy, we have to know some things. First, that emotional response is not necessarily an empathic one. Like, there is little research done on the empathic part, that there are still ongoing research in neuroscience to understand the empathy in humans, and that there is no universally accepted model for empathy. So it's the beginning, I think. Okay, so now let's go to the last part, and it's the part where we want to express emotion back to the user. And for this, again, like in the first part, we cannot move, we cannot make face expression. So we can use emojis, like this, for example. And these are massively used on messaging app, as you may know. But the emojis give challenges because it can have different meaning. I think you know what I want to say. And they can be contradictory, and they can be interpreted differently based on the culture, on the experience, etc. We have this tool called Deepmoji that can translate a text to the most possible emojis, like here. And this takes into account the sarcastic sentences, so I think it's a really good tool. So, my conclusion is that most of the current method tackle the emotion detection, but only the ECM try to express, to generate emotional responses, but it doesn't mean that it is empathic. So the challenges now are these 4. Like, we need more quality training data. We want to be good in emotional and content level information. We want to consider the full end-to-end experience for chatbots, because we have frameworks for one of these 4 parts, but not for all of them at the same time. And we want to model the emotions throughout the conversation. And that's it for me. So thank you. And if you have questions, I'm here.
So thank you, Jacky. So we have time for 1 or 2 short questions. I don't think we need a microphone, so please speak up.
Could you go back to the slide with the architecture of the model?
The ECM.
Yeah, so the next one. So really related to both. So I'm still not quite sure what you mean by storing the emotion category and the internal and external memory in this emotion embedding. So can you explain this part again?
Okay, I did not explain this part, because I'm not really sure how it works, but the first part here is the sec-to-sec model, okay? Because we have the encoder, and we get the attention of the interesting words in the sentence, and then we decode it with the help of the emotions. And so here as I said, we have to set the emotion we want. We put the emotion we want in the input with the utterance, okay? and then we want to generate, the decoder will take into account this emotion to generate the response. So I cannot explain these 3 blocks, but they use it to decode and to create the emotion.
Okay. Just time for one quick question.
I might have one.
Yeah.
So I'm actually curious about the choice of the 6 emotions. Why do you choose the Ekman versus the Plutchik? Because Plutchik has more nuance in it. So you'd imagine that that would be more useful for your purposes.
Yeah, I think it can be more useful and more precise. But I think most of the time people want to have less emotion to classify the sentence in the categories. Because it's easier, let's say when we deal with classifiers and supervised learning, it's easier to have good results with less categories than having good results with a lot of categories. And 32 categories is really high.
But you could have chosen one of the layers, right? You could have chosen like the 8.
Yeah. Yeah, of course.
So because okay, yeah. So
Yeah, I think it's a choice of facility of the researchers that they can compare their results to the previous results. Okay, but of course in the future they will use a lot of more emotions categories, I'm sure.
Okay, so let's stop here. Thanks once again.
Thank you.